All right, here's answers to that review quiz that we did and sort of how to do the questions. With this one here, you're adding integers. They're different signs, so you subtract the two numbers. So that when you subtract the two, you get 22, and the larger number is positive, so your answer is positive. Okay, in this one, same kind of thing, but here I'm subtracting, and this is negative as well. So if there's two negatives in between numbers, I can add the opposite. That's the rule we talked about in class. And so then you would add those two numbers. 86.64, I think, is the answer to that. Next question, you have to multiply these numbers. 5 times 5, that little snowflake means multiply. So 5 times 5 times 3 times 115. Let me do that. Where's my calculator? Here we go. All right, clear. So 5 times 5 times 3 times 115 is 8625. Let me move that calculator over. 8625. Okay, so it's 8625. But now I have to worry about a sign. Two negatives will cancel each other to be positive. So those are positive. Here's another two negatives, so they cancel to be positive. And there's no more negatives, so my answer will be positive. Okay, the next question, dividing fractions. I can invert and multiply. So it'd be 8 over 3, and there's a negative sign in there somewhere. So it's negative, and then I just multiply. 4 times 8 is 32, and that's a 5. 5 times 3 is 15. So you can leave it like that. If you wanted to write it as, I think that's negative 2 and 2/15. That would be correct as well. Or you can write it as a decimal. I forget what the decimal comes out to, but it'll be negative 2 point something. These would be preferred though, the fraction versions. Okay, the next one, I'm dividing common bases. This is an exponent question, so I subtract exponents. So this would be 4 to the 2 minus a negative 5. Now minus a negative, those two would cancel. So this would be 4 to the 2 plus 5, or 4 to the 7th. If you figure that out on your calculator, I think it comes out to 16,384. Okay, next one. Write that number in scientific notation. So it'll be, you have to move the decimal so it's right behind the first non-zero number. So it'll be 8.76 times 10. It's a very small number, so it'll be negative. And then it's 1, 2, 3, 4, 5, 6, 7 places I had to move it. So 8.76 times 10 to the minus 7. Next one, convert from scientific notation to decimal notation. So I have to move my decimal. Since it's negative, it's a small number, so I'll move my decimal 5 places that way. So it'll be 0.0000602. So I needed to move it past the 6, that's 1, and then another 4 zeros. Okay, next, what SI unit is used to measure the following? Distance would be meters, energies, joules, times, seconds, volume, liters, and mass, typically kilograms. Although if you said grams, I'd be okay with that too. All right, next one, number 9. How many sig figs do each of these numbers have? Zeros behind the decimal always count. So this would have 3. Zeros, any leading zeros, never count. So this one would also have 3. This one here, a trailing 0 in front of a decimal, like the decimal would be here if we wrote it in, don't count. So this one only has 2 sig figs. This one, since there's a decimal place there, the 0 out front does count. So there'd be 3 sig figs there. Okay, if I want to convert from centimeters to meters, if I look at the chart, let me just pull it up quick. Right there. Here's a chart. So to go from centimeters to meters, it's up 2. Okay, so I'd have to move my decimal 2 to the left. 1, 2. So 0.567. Okay, from milliliters to liters. Milliliters to liters. So it's 1, 2, 3 to the left. So I got to go 3 to the left. 1, 2, 3. So I have to now add another 3 zeros to that. So it's 0.000 and then 0.00556. Notice I think there's 5 zeros there. Okay, kilojoules to joules. So kilo down to joules is the base unit. So it's 1, 2, 3 to the right. So I have to move this 3 to the right. 1, 2, 3. 5.68. All right, next one, milligrams to kilograms. Milligrams would be down here to kilograms. 1, 2, 3, 4, 5, 6 to the left. So I have to take this, and the decimal would be assumed to be here, 6 to the left. So it would be 4 to get past that, and another 2 zeros. So 0 decimal, 0.05890 kilograms. All right. Calculate this expression for given these things here. So here's my formula. VI is 0 times the time is 5, okay, plus 1/2 times acceleration is 9.8 times the time squared, 5 squared. So 0 times anything is 0. Okay, half of 9.8 would be, I think, 4.9. And then 5 squared is 25. So now I have to go 4.9 times 25. Do I have an answer for that? A sec. Oops. 4.9 times 25. Oh, 122.5. This is equal to 122.5. Now going back to my question, I have 1 sig fig, 2 sig figs, 1 sig fig. So my answer can only have 1 sig fig. So here's the first sig fig. The rest have to revert to zeros before the decimal point. So it'd be 100. That would be the correct answer for that question, according to sig figs. All right, dealing more with some sig figs here to figure out how many, or to round this correct to sig figs. If I have to round it to 2, there's 1, 2. I look one more, it's bigger than 5, this one has to go up. So the answer to that would be 5.8. 2 sig figs here, here's the first, there's the second. This is more than 5, so this one goes up. So it's 2, 6, but I can't just write 26 because that's completely different than 259. Remember, I'm rounding. So I can think to myself, is this closer to 250 or 260? And it's closer to 260. Round to 3 sig figs, zeros out front don't count, so I just write those in. And then there's 5, a 6, there's 2. The third one, this one's larger than 5, so this one gets bumped up. Okay, there's your sig fig questions. Okay, now this question says, and it's one of those inverse direct variation kind of questions where you have to find a constant and then use the constant. So here is the formula. It says if W is 15 when D is 5. Okay, so W is 15 equals K times D is 5. So I want to solve for K, so I'll divide both sides by 5. So I have that. I'll divide this by 5 because I want K by itself. If I divide it here, I have to divide it there. So K is equal to 15 divided by 5 is 3. So now I can write my formula. Instead of W equals K times D, I know what K is. So I can write it as W equals 3 times D. Now in the question over here it says, figure out what W was when D is 10. So W would be equal to 3 times whatever D is, 10. So 3 times 10 would be 30. Sig figs, 2, 1, 2. So I have to go to 1. That's 1 sig fig, so I'm good. Okay, inverse and direct variation. Inverse is where one thing goes up, the other one goes down. Direct variation is when one thing goes up, so does the other thing. Or if one thing goes down, so does the other thing. Examples of an inverse function might be something like power is equal to work over time. Notice there's a fraction, inverse function. And this means if you do something, if you do a bunch of work, I guess, that the power you required would go up when the time would go down. So the shorter you do something in, the more power you've exerted. An example of direct variation might be force equals mass times gravity. So gravity would be the constant. In this case here, if the mass goes up, so is the force. So if I say have to lift something, if I have to lift something that's heavier, it'll require more force to do that. Okay? So those are examples of inverse and direct variation. Okay, draw a position time graph for the following. So on the left-hand side here will be distance or position, and it'll be in meters. And on the bottom will be time, and it'll be in seconds. So I'm going to start here at 0 and 10, okay, 20, 30, 40 seconds. And then up here I'll go 10, 20, and 30. Okay, so from 0 to 10, it goes forward 10 meters. So it starts here, and in 10 seconds, it gets up to 10 meters. So I could draw a line. Then from 10 to 20 seconds, it stands still. So from 10 to 20, it doesn't move anywhere. It's just flat. Then from 20 to 30, it goes forward again 20 meters. So if I started at 10, I'd have to go up to 30. So I'd have a point up there somewhere. Draw a line. And then finally, from 30 to 40 seconds, that's this time interval, it goes backwards 30. So it would be go down. So this way would be forward, down would be backwards. So down, it's going to go 30. If it starts at 30, it's going to end at 0. So your position time graph should look something like that. Okay, now here's some formula questions. So it says a bike travels 100 kilometers, 5.23 hours. What's its velocity? So I have a distance, I have a time, I'm looking for velocity. If I look at my formula sheet, right there's a formula that has those three things in it. So I'll write the formula down. Velocity is equal to distance over time. They're looking for velocity, okay? So the distance is 100.0 kilometers divided by 5.23 hours. So if I divide that, get a calculator, whoops, 100 divided by, divide 5.2, whoops, 0.23. So it comes out to 19.12. So 19.12 kilometers per hour. Looking at sig figs, I've got 4, I've got 3, so at most I can give 3 sig figs. 1, 2, 3. This one's less than 5, so I leave it there. So this would be 19.1 kilometers per hour. Okay, almost done. Just a few more questions left. Same bike starts at rest, so VI is 0. Accelerates to 2 meters per second. So this is a velocity. That'd probably be my final velocity. It does that in a time of 10 seconds. So the question is, what is the acceleration? Whoops, spelled that wrong. What is its acceleration? So I need to find an A. So I need to find a formula that has those 4 things in it. Let's look to see if we can find one. A T. Whoops, that's not it. Formulas. Okay, VI, VF, yep, A, oh, but there's no T in this one. Oh, here's one. VF, VI plus AT. That's the one right there. VF equals VI plus AT. Oops. VF equals VI plus AT. And they're looking for the acceleration. Okay, well, we can solve for acceleration, or you can plug numbers in, whichever works for you. Why don't we plug numbers in this case? VI is 0. Final velocity is 2. So 2 meters per second is equal to acceleration, I don't know, but I know the time is 10 seconds. Okay, so 0 plus anything doesn't change it, so it'd be A times 10 is equal to 2.00. To solve for A, I'll divide both sides by 10. So A is going to be equal to 0.2. Let's check sig figs. There's 2 here. There's 1 there. I guess I only have 1 sig fig. So my answer would be 0.2. And this would be, this is meters per second. And this is, so this is meters per second. And this is also seconds. So my units would be meters per, if there's 2 seconds on the bottom, it'd be seconds squared. Okay, so 0.2. All right, next one. Same baker averages a velocity, so this would be a velocity average. This would be a time. Question is, how far did they travel? Okay, so again, I have to look for a formula with a velocity, a time, and a distance. Velocity, right there. V equals d over t. So V equals d over t. And I want to solve for d. So I don't want this t there. So I'm going to times this side by a t. If I do it there, I have to times it over there. T's cancel, leaving me with d is equal to times velocity, or TV. Okay, the time is 5 hours, times the velocity is 30.0 kilometers per hour. The hours cancel, so I just have to go 5 times 30. That would be 150 kilometers per hour. Sig figs, I should put it equals d here. Equals d. So sig figs, 3, only 1 sig fig. Oh, great. So 150 kilometers per hour, but I have to do 1 sig fig. There's 1, there's 2. I guess I have to ask myself, is this closer to 100 or 200? If this is a 5, typically we'd bump that up. So if I had to round it to 1 sig fig, it'd be 200 kilometers per hour. Okay, a cat. Oh yes, we're dropping cats again. Gotta like that. Okay, drop from rest, so that would be initial velocity of 0. 10 seconds, that's time. To reach the pavement, trampoline. How high up was the cat when it was dropped? So they want to know a distance. Drop from rest, 10 seconds. How high up was the cat? So I need a velocity, a distance, and a time. Oh, but also it's dropping, so there has to be some gravity involved. 9.8 meters per second squared. Okay, well, let's take a look at our formulas. I'm looking for a V, a T, a D, and a G. A D, a VI, a T. Oh, maybe it's that one right there. They're looking for distance, right? Initial velocity, I know. Time, I know. Gravity, I know. Time, I know. That's my formula right there. Okay, so D equals... where am I? Here we go. D is equal to VIT plus 1/2 AT squared. So distance equals initial velocity, drop from rest, so this would be 0, times the time, 10 seconds, plus 1/2 times acceleration is gravity because you're dropping it, so that'd be 9.8 meters per second squared, times the time is 10 seconds, and that's squared, seconds squared. Okay, 0 times 10 is nothing. So it'll be 1/2 times 9.8, that's 4.9 meters per second squared, times 10 seconds squared would be 100 seconds squared. So the seconds squareds cancel. Now I just have to go 4.9 times 100. So that'd be 490. 490 meters up. That's how high the cat was dropped from. That's a pretty good distance. Let's check sig figs. 2 from gravity, 3 from there. You got to convert this to 2. It's already at 2 because it's 0 without a decimal doesn't count. All right, make up 5 questions. I'd encourage you to do that. Just make up some questions that that you might use and show them to a buddy and see if they can solve it, and vice versa. Always a good idea. Or go to the quizzes too. The quizzes will have lots of questions you can try. Okay, we're on that one. Okay, difference between kinetic and potential energy. This is kinetic energy. You might want to talk about that. You can use formulas maybe to indicate which is which. Kinetic energy also is an energy of motion. So if something is in motion, it has kinetic energy, whereas potential energy is stored energy. Okay, so or it's a type of energy based on position. So if you lift a rock up high, just because it's up high, it has more potential energy than if it was on the ground. Okay, so discussing something like that would be what you'd want to do. Oh, sorry, my TV turned on. Let me pause again. Okay. All right. So that's sort of a definition type question. All right. Here's another one. 500 kilogram objects falls from a height of 100 meters to half of its own height. So what will its kinetic energy be? Okay. Well, I've got kinetic energy is equal to 1/2 mv squared. I have a mass, but I don't have a velocity. Nor do I have the kinetic energy. Can't really use that formula. However, I do know that according to the law of conservation of energy, that the energy total in a system is equal to the energy potential plus the kinetic energy. So if I can find out its potential energy and then come down half of that, then that should be what the kinetic energy is. Let's try that. So potential energy is mass times gravity times height. Oh, I've got all of that stuff. This is what I want to do. So the mass is 500 kilograms. Times gravity is 9.8 meters per second squared. Times the height is 100 meters. Okay, so if I multiply, that's a decimal there. If I multiply all that stuff out, see, I better go do that. 500 times 9.8 times 100. 500 times 8 times 100. So it's 490,000 joules. 490,000, because I'm determining potential energy, this would be in joules. 2 sig figs, I'm good. But now that is the energy if it was right at the top. So that would be the potential energy. And if it was at the top and it's not moving, there'd be 0 kinetic energy. So if I went halfway down, I would just divide this by 2. So the potential energy at halfway down would be 490,000 divided by 2. Or that'd be a 2, a 4, I think, and a 5, and then 3 zeros. So that would be halfway down 245,000 joules of energy. Again, if I look at it being at the top, and here's the bottom, at the very top, I've got 490,000 joules of energy. If I let that thing go down to halfway, it's going to have half of that amount of energy, or 245,000 joules. And that is potential energy. If I was looking at kinetic energy, at the top it's not moving, so it's got nothing. In the middle, though, these things go opposite direction, right? Potential decreases, but kinetic increases because it's going faster. But all the time, these two have to add up to a constant of, in this case, it was 490,000 joules. So the kinetic energy halfway down has got to be 245,000. And that was what the question would be. So that would be my answer. Now, just to finish it off, though, if the thing fell all the way to the bottom, how much potential energy would it have? should be 0 because now it's stopped. Kinetic energy, though, just before it hits the ground, it should be maximized. So just before it hits, it should have 490,000 joules of energy. And notice that at any point as that object falls, the potential and kinetic are always going to add up to the same number. It's always going to be 490,000. Good question. All right, calculate the power exerted to take a 50 kilogram object to a height of 10 meters in a time of 15.5 seconds. Another great question. So from my formula sheet, right there, power, where's power? Power is equal to work over time. Here we go. Power is equal to work over time. Okay, work, oh, I don't have that. I have a mass, and I have a distance, or maybe a height, and I have a time. I guess I have a number there, but I don't have work. Let's try and figure out work. Work is equal to, what's my formula again? Force times distance. Force times distance. I have a distance. Yeah, I don't have a force. Okay. Force. Force equals mass times gravity. Okay. Force is equal to mass times gravity. Do I have mass? I do. 50.0 kilograms. Times, do I know the gravity? Yep. 9.8 meters per second squared. So if I multiply those two, 50 times 9.8, calculator, 50 times 9.8, 490. Can we just do that? 490. So this would be 490. Forces are measured in newtons. Okay, now I've got a force, so I can take this and plug it in right there. So the work done on that object is equal to force, 490 newtons, times a distance of 10 meters, 10.0 meters. So 490 times 10 would be 4,900. Newton meters, those are measured in joules. Work is always measured in joules. Okay, so now I've got work and I can plug it right in there. So it'll be power is equal to the work exerted, 4,900 joules of work, divided by a time of 15.5 seconds. And that's equal to, yeah, where's my calculator? 4,900 divide 15.5. Sorry, I should have had it out there. So 316.129. 316.129 joules per second are watts. Now let's do sig figs because we're at the end. 3, 3, 3, but gravity was 2. So I got to go to 2 with this one. Okay, so here's the first one. Second one, I go one more. It's more than 5. This one gets bumped up, and then that gets put to be a 0. I don't put a decimal there because then it would give it 3 sig figs. So 320 watts, that was the power exerted. All right, one or two last questions. Calculate the force of a 25 kilogram baby. 25 kilogram baby, that's like 55 pounds. Yeah, that's a big baby. All right, but force is equal to mass times gravity. I have a mass, 25.0. I have gravity, that's kilograms. Gravity is 9.8 meters per second squared. So I just have to go 25 times 9.8. Okay, 25 times 9.8, 245. So the force of that baby is 245. Forces are always measured in newtons. Sig figs, 3 sig figs. Gravity's 2, so I have to round this to 2. So 2 is good. The next one, the one after is 5 or greater, so this has to go up to a 5, and that gets put to a 0. Okay, so is it closer to 240 or 250? We always say if it's 5 that you round up. All right, last question. Calculate the work done to lift the baby to a height of 2 meters. Yeah, some baby. All right, so work is equal to force times distance. I just figured out force on the last question, right? 250. I guess if it was all one question, I might use the 245, but if it's a separate question, maybe I'll use the 250. Okay, so the force done is 250 newtons times a distance of 2 meters. Okay, work is always measured in joules, so a newton meter is the same thing as a joule. 250 times 2 will be 500 joules. 3 sig figs, 2 sig figs, I got to go to 2 sig figs. I can't really do 2 sig figs if it's listed like this, so maybe I'll change it to scientific notation. So 5.0 times 10 to the second joules, that would work. Or if you wanted to convert this to kilojoules, so 0.50, you wouldn't put another 0 there because that's an extra sig fig. So 0.50 kilojoules. Okay, hopefully that helps with the review sheet. Give me an email or send me a text if you have questions.